Okay, so since we've done pretty much exhausted everything we can do with operations with fractions, even throwing in the variables for the algebraic fractions, now let's take a look at what happens when we throw in the mixed numbers. Now remember, when we talked about the algebraic fractions, we said you never convert it to a mixed number. So that means the good news is there won't be any variables in these. It's all strictly numerical. So we're going to set this up 5½ plus 3 2/5, just like we would with a whole number or with our plain fractions. You'll notice that what we do is we line up the fractions at the end of the number almost like it's just the last digit of the number. And that's really what it is. That fraction is just the final digit at the end of the number. And when we add, just like we do with whole numbers, we're going to start at the right and work our way backwards to the left. Adding the fractions first because that's our last digit, and moving back and carrying if we need to. Well, we still have to find a common denominator. Now, your textbook, I believe, shows just rewriting the fraction. I always rewrite the whole number portion too, otherwise I lose it sometimes. What's my common denominator going to be between 2 and 5? 10. Very good. At this point, hopefully you're becoming pretty good at finding those common denominators. If you're not, let me know and I can go over some more with you to help you get better at that. So what do we have to do to the 2 to turn it into a 10? Times 5. So 1 is also multiplied by 5 to give us 5/10. What's going to go here? 4. 5 times 2 makes 10, so 2 times 2 makes 4. And now we add. We start on the right and work our way back to the left. 5/10 plus 4/10 becomes 9/10. We combine the counts. 5 plus 4 is 9, and we keep that same name of tenths. And now we move over to the next digit to the left. 5 plus 3 is 8. So 8 and 9/10. Now, as you've learned in this class, it doesn't stay that simple. It gets a little more difficult. I'm just going to go ahead and start writing these vertically instead of doing them horizontally and rewriting them. So let's take 4 3/4 plus 7 5/6. We need to find our common denominator. So we have 4 and 6 as our denominators. The common denominator would be 12 would be the least one. Very good. What's going to go up here? 9. Good. 4 times 3 to make 12, so we have to do 3 times 3. Gives us 9. What's going to go here? 10. Good. 6 times 2 makes 12, so we have to do 5 times 2 to get a 10. And now, just like up above, we start on the right, we work our way back to the left. We'll do the fractions first. 9/12 plus 10/12 is 19/12. What's wrong with that? It's improper. So we can reduce that to 1 and 7/12. And now, just like with whole numbers, we're going to keep part of it. Well, that's the fraction digit. So I keep the fraction, the 7/12. And I carry the whole number, the 1. So now I have 1 and 4 is 5, plus 7 is 12. So that's 12 and 7/12. Any questions? I'm going to have you try one. So 9 and 4/5 plus 6 and 3/8. See what you come up with for that. What's my common denominator going to be? 40. What's going to go here? 32. And here? 15. Okay, what's next?
47 over 40.
32 plus 15 is 47 over, we keep the common denominator 40, equals 1 and 7/40. Okay, so we keep the 7/40ths and we carry the 1. Yep. 1, 9, and 6 is 16. So 16 and 7/40. How we doing? A little bit better than the last hour?
My kid showed me an easier way last night to put it into an improper fraction so you can do it in the calculator.
Well, on your calculator, you can actually just do
You can just put them in.
9, press your ABC key, 4, press the ABC key again, 5. That enters the 9 4/5, plus 6 ABC, 3, hit the ABC key again, 8, and then hit equals. And it will spit out 16 and 7/40ths.
Wasn't sure how to do the whole number, so I was making them into improper fractions so I could do it later.
Oh, sure. Yeah, you don't even have to turn them into improper fractions. It'll do it for you. That calculator is a handy little tool. I won't deny that. So any questions? Okay, let's jump to subtraction since that's similar. Let's do 8 3/4 minus 2 and 2/5. Just like addition, we must have a common denominator, which will be what? 20. We have 4 and 5 are our denominators, and the least common multiple is 20. What's going to go up here? 15. And down here, 8. Good. Now, just like whole numbers, we're still going right to left, but we're subtracting. So 15 minus 8 makes 7, and we keep the name of 20ths. 8 minus 2 is 6. Well, again, it's not going to stay quite that simple. This gets a little trickier with subtraction. So we need to find a common denominator. What's the common denominator going to be? Careful. 24. What's this going to become? Three times what makes 24? 3 times 8. So 1 times 8 is 8. There we go. And what's going to go down here? 9. Good. 8 times 3 makes 24. So 3 times 3 makes 9. Now we go to subtract here. 8 minus 9 is a problem, isn't it? So in whole numbers, what we would do is we would borrow. In fractions, what we're going to do is borrow. So borrow from the 7. This is now a 6. The problem is what we just borrowed was one whole object. Fractions represent pieces of the whole object. So what do we need to add to this 8? Well, we need to add one whole object to it. How many pieces are in it? 24. So what we're adding to that numerator is the denominator, because the denominator tells us how many pieces were in that one object that we borrowed. So 8 plus 24 is 32. So we now have 32 24ths. So then we do 32 minus 9 is 23 24ths. We keep the same name yet. And then 6 minus 4 is 2. Let's look at another one of those. What's that? You got her? Okay. So let's do something like 9 and 2/5 minus 3 and 2/3. What's my common denominator going to be? 15. What will this be? 6. Good. 5 times 3, so 2 times 3 makes 6. What's this going to be? 10. Good. 3 times 5 make 15, so 2 times 5 makes 10. We go to subtract. 6 minus 10 is a problem. What do we have to do? Borrow from the 9s. That's an 8. What do we have to add here? 15. That one object we borrowed, the denominator of 15 tells us how many pieces are in it. So what we have up here is 6 plus 15, or 21 fifteenths. And then 21 minus 10 is 11 fifteenths. And 8 minus 3 is 5. What do you think? More fun than a barrel of rabid monkeys? Probably. Good. Let's have you guys try one. I'll give you a minute for that one. Our common denominator will be 12. This is going to become 4 and 9. Good. We go to subtract. 4 minus 9. We need to borrow to make this 6, and this will become 16 twelfths. Good. 16 minus 9. Careful. 7 twelfths. And 6 minus 5 is 1. What do we think? Well, our next step. Oh no. No, won't put variables in with this. Trust me. Let's do 5 1/3 times 2 and 1/4. How do we multiply mixed numbers? Well, the process to multiply mixed numbers is actually a pretty difficult one. In fact, if you went over here to the university across the street and found 10 math majors, I would be surprised if even one of them could do it correctly. So how is it that I expect you to do it? Well, we're not. We're going to avoid it. How do we normally get away with multiplying mixed numbers? We change them into improper fractions. 5 1/3. Remember how to change it into an improper fraction? 3 times 5 is 15, plus 1 is 16. Good. The 2 1/4. 4 times 2 is 8, plus 1 is 9. Good. And then what? We can simplify. This is multiplying fractions again, so we can cross cancel. 3 and 9 divided by 3 to give us 3 and 1. Or 1 and 3. 16 and 4 both divide by 4 to give me 1 and 4. So now we multiply. 4 times 3 is 12. 1 times 1 is 1. So 12 over 1 or just 12. Now they don't all work out to be quite that convenient. This one just got lucky. Anybody curious as to how we would actually multiply the mixed numbers if I wanted to do it that way? Nobody? Okay. So anyway, let's look at some examples that don't work out quite so neatly. Tell me what to do. Okay, turn it to improper, yep. So 3 4/5 will become 19 fifths. Good. The denominator never changes, so the 5 will stay a 5. But we have to do 5 times 3 is 15, plus the 4 is 19 fifths. So over here, the denominator is going to be 3. That won't change. 3 times 7 is 21, plus 1 is 22. Now I could cross cancel here if there was anything to cross cancel, but in this case, there's not. So 19 times 22 is 418, good. 5 times 3 is 15. Now we do still have to reduce it. That's where this is a little challenging for us. So we take our 418 divided by 15. 15 does not go into 4. 15 goes into 41 twice. That's 30. We subtract to get 11. Bring down our 8. 15 goes into 118 7 times. 7 times 15 is 105. There's 13 left over. So that's 27, and then there's 13 15ths left over. So 27 and 13 15ths. Remember, your remainder is what goes back above your denominator for your fraction portion. What do you think? Really, the toughest part is converting it back into a mixed number when you're done. What if you guys try one? Give that one a shot. Talk me through it. Okay, 4 times 2 plus 3 is, careful, 11/4, right? Over here, 5 times 1 plus 3 is 8/5. And then 4 and 8 reduced to 1 and 2. And then 11 times 2 is 22. 1 times 5 is 5. 5 goes into 22 4 times, with 2 left over. Not so bad? Okay. How would we divide mixed numbers? Yeah, we're going to change it into multiplying just like we did with any other fraction. So we're going to start out by doing exactly like we did with our other multiplication and turn these into improper fractions. So 4 and 3/8 will become 35/8. 2 and 1/5 will become 11/5. Can I now cross cancel the 35 and the 5? Say no. Why not? Because at this point it is just, it's still division, right? You have to turn it into multiplication. You can only cross cancel in multiplication. So we have to turn it into multiplication. So the 35/8 will stay the same, times 5/11. At this point, now that it's multiplication, now we could cross cancel if there were anything to cross cancel. Unfortunately, at this point, there's nothing that we can cross cancel. So we go ahead and multiply. 35 times 5 is 175. 8 times 11 is 88. 175 divided by 88 goes in there once with 87 pieces left over. So 1 and 87/88. Any questions? Let's have you try one. So 3 1/4 divided by 2 4/5. We'll give you a couple minutes. Tell me where to start. Okay, so 4 times 3 plus 1 gives us 13/4. Good. How about over here? 14 over 5. Is this multiplication now? Nope, still division. Can I cross cancel? Nope. You still have to change it to multiplication. So 13/4 stays the same. What's next?
5/14.
Times 5 over 14. Good. And then
65 over 56.
we multiply it. 13 times 5 is 65. 4 times 14 is 56. That's 1 and 956. Anybody have any questions? Now, just like with the addition and subtraction, you can use that ABC key to enter these in the calculator. I'm going to leave you to figure that out now that you know how to enter a mixed number using the ABC key twice. If you have problems with it, let me know and I'll talk you through it. But I'll let you play around with it to get it to work. It's the same process. So now that we can work with these mixed numbers and algebraic fractions, what happens if I mix my mixed numbers with just whole numbers? Like let's say I have 8 plus 3 and 5/8. What am I going to do with that? Well, remember we said the 5/8 is just the last digit of the number. So when I go to work with it, I line it up. Even though there is no fraction on this 8, I have to leave a spot there to line up the 5/8 with. What's going to get added to the 5/8? Absolutely nothing. That's just going to be 5/8. The 8 gets added to the 3 because those are the whole numbers. In fact, now be careful with this because I don't want to confuse you. You could think of this as being 0/8. So 0 plus 5 makes 5. Now the only reason I show you that is because if we're going to subtract, we have to think of it that way. Let me show you what I mean. Let's say I have 7 minus 2/5. Or sorry, not 2/5. Let's do 3 2/5. So I have 7 here, my 3 2/5. When I go to subtract here, I have to have something to take that 2/5 away from. So that's why I do have to think of this as being like a 0/5. Just like if I was doing a decimal, I know we haven't covered decimals yet, but if I have, 4.2 minus 1.38, I have to make that 4.20. I add a 0 on the end of it. Same thing here. I add that 0 there, 0/5. But now before I can subtract 2 from it, I do have to borrow from the 7. That's a 6. I borrowed one whole object, which is 5 pieces, so this is now 5/5. And now I can subtract. 5 minus 2 is 3/5. 6 minus 3 is just 3. So it's not horrible, but it can be a little tricky dealing with a whole number and a mixed number, especially when we're subtracting. What if we're multiplying? What if I have 3 1/5 times 5? Well, the 3 1/5 still has to become an improper fraction. That's going to be what? 16/5. Good. 5 times 3 is 15 plus 1 is 16. To multiply it by a whole number, though, I have to change that into a fraction. 5 becomes what as a fraction? 5/1. And now I can work with it just like any other fraction. In fact, I can cross cancel. The 5s divide by 5s to give me 1 and 1. So this one's simple. 16 times 1 is 16. 1 times 1 is 1. 16/1 is just 16. So now that we're okay with working with fractions and mixed numbers, what happens if I give you something like this? Three-fourths x equals 15. Now, a lot of people look at this and they panic just a little bit. I just combined two of your least favorite things, fractions and solving equations and variables. But this here is really no different than having an equation like this. How would I solve this equation here? What would I have to do? Divide by 7. X was multiplied by 7. I solve by dividing by 7. It gives me x equals 4. Right? Over here, what's been done to x? It's been multiplied by 3/4. I solve it by dividing by 3/4. So x equals 15 divided by 3/4. So this is 15 over 1 times 4 over 3. I'm multiplying by the reciprocal. I can actually cross cancel the 15 and 3 to give me 1 and 5. 5 times 4, 20. 1 times 1 is 1. 20 over 1 is 20. X equals 20. So it's not much more of a problem when I go to something like this. What would I do here? I divide by 2 1/5. So here I'm going to get x. Over here I've got a little work to do, don't I? Now if you're using your calculator, yeah, you can just punch it in. Since I'm doing it by hand, I've got to write it out like this, so I'm ready to go. Now I'm going to change them into improper. 4 times 7 is 28, plus 3 is 31/4. Still divided by 5 times 2 is 10, plus 1 is 11/5. And now I still have to change it into multiplication. So it's 31/4 times 5/11. Then I'll multiply. 31 times 5 is 155. 4 times 11 is 44. And now I have to reduce that to a mixed number. 155 divided by 44. 44 goes in there 3 times, which would be 132, right? Which leaves us with 23. So we have 3 and 23/44. Does that sound right? Yep. Good. Any questions? You look confused, Kinsey. So you would just enter 7, ABC3, ABC4. Wonder what it was doing to you. I'll try it one more time and see if it works out. Then we'll. So 7, ABC3, ABC4 divided by 2, ABC1, ABC5. Okay, so that would have given you the upside down of that, the reverse of that. So now it's not much of a stretch to jump to a problem like this. Now again, this is just like an equation like this. 3x minus 2 equals 19. It's To solve this equation, what would I do? I'd add 2, right? And then I would divide by the 3. Bless you. Does that look familiar over here? So over here, I'm going to add 3 1/4. That leaves me with my 2/5 x. 2 7/8 plus 3 1/4 is 6 1/8. You may have to write that off to the side and actually add it, but I'm going to, just for the sake of time, I'm going to give you that. Then what would we have to do? Well, x has been multiplied by 2/5, so to get rid of it, we're going to divide by 2/5. So that's gone. It would leave us with just x. We have 6 1/8 divided by 2/5. I'm going to combine a couple steps here. 6 1/8 becomes 49/8. Then I'm going to do this times 5/2. I'm going to do the reciprocal. 49 times 5 is 245. 8 times 2 is 16. Which reduces to 15 5/16. Any questions? Anybody struggling to reduce this to a mixed number, the 245/16? So you got 245 divided by 16. 16 does not go into 2, but it does go into 24 once. Leaves you with 8. Bring down the 5. 16 goes into 85 5 times. 5 times 16 is 80, so there's 5 left over. How are we doing? Let's have you try one. Give that one a shot in your notes. Where do we start? We're going to add 5 1/2. So that's going to be gone, leaving us with 3/4 x. Adding 5 1/2 over here gives us 11 7/8. Then what? X is being perfect. It's being multiplied by 3/4, so we're going to divide by 3/4. So that's gone, leaves us with x. We have 11 7/8 divided by 3/4. This is going to become 8 times 11 is 88, plus 7 is 95/8. This is going to be times 4/3. And we can cross cancel the 4 and the 8 to give me 1 and 2. 95 times 1 is 95. 2 times 3 is 6. 95 6 is 15 5/6. How many of you had 15 5/6? A few of you? So the key here is just staying patient with your fractions. It's the same process as solving equations from before. But we can add some steps to it, like this. So if we look at this, if we there's a fraction here, obviously it's all divided by, it's all over the 11 there. But if you look at this, there's another way to look at it rather than looking at it as a fraction. You can look at this as what's happened to y what's been done to the y, to the variable, is it was first multiplied by 5, then 2 was subtracted from it, and then the whole thing was divided by 11. Because order of operation says you have to do everything on top first, and then you do the division. So if I'm going to solve this, what's the first thing I have to get rid of? What was the last thing that was done? Dividing by 11. So the first thing I have to get rid of is dividing by 11. And how do I do that? I did the opposite. I multiply by 11. So that gets rid of that, leaving me with 5y minus 2. Over here, I multiply by 11 to get 33. Now, this is just like equations I have solved several times before. What do I have to do with it? Add 2. So that's gone. I have 5y equals 35. And then I'm going to divide by 5. X equals 7. Sorry, y. I don't know where I got the x from. Yeah, y equals 7. Sorry. Yeah, y is, it's still y. It's my fault. What do you think? Let's have you guys try one like that. Give that one a shot. What are we going to do first? Times 4. You got it. That 4 is gone. We have 5x plus 8. So all that happens here is this 4 disappears. But we do have to do something to the other side as well, which is times 4. 7 times 4 is 28. Then what? Subtract 8. So we're left with 5x equals 20. And then divide by 5 to get x equals 4. We're dividing. So that was not too bad, right? Well, I'm starting to get a complex here. Okay, so yeah, it is going to get worse. What would we do here? Cry just a little bit? Maybe. What do we have to do first? Well, just like up here, right? The first thing we did up here is we multiplied by the 4 to get rid of it. Down here, we're going to multiply by 7/8. So we're left with 2/3 x minus 1/4 equals. Well, we have to multiply this by 7/8 as well, don't we? So let's do that. 4/5 times 7/8. Do I have to do any reciprocals or anything? No, I'm just multiplying. So, but I can cross cancel. 4 and 8 both divide by 4. Give me 1 and 2. 1 times 7 is 7. 5 times 2 is 10. So this is 7/10 here. So I'm going to pause, take a breath. Any questions? Same process, is just a little uglier because we had to calculate with the fractions. Now what would we do next? Add the 1/4. That's now gone, leaving us with just 2/3 x. We have to add 1/4 over here, which means we must find common denominator, which will be 20. This is going to be 14 20ths, and this will be 5 20ths, which adds to give us 19 20ths. And then well, x is multiplied by 2/3. We're going to divide by 2/3. These are just x. So we've got 19 over 20 divided by 2 over 3. Can I cross cancel the 2 and the 20? Right now it's divide, right? So I change it to times 3 over 2. Now I can cross cancel. Unfortunately, nothing there. But I do have 19 times 3 is 57. 20 times 2 is 40, which reduces to a mixed number of 1 and 17/40. Any questions? I think you guys want to try one of those. Okay, you're going to whether you want to or not. Give that one a shot. Where do we start? Perfect. Multiply by 1/3 to make that go away. So that leaves us with 2/3 x minus 1/4. Over here we have 1.5 times 1/3. Or change the 1.5 into a mixed or to improper, so it's 3 over 2 times 1 over 3. And conveniently, the 3's cross cancel to give us 1's, so we get 1/2. And then we add 1/4. Very good. So that's gone, giving us just 2/3 x. Over here, 1/2 and 1/4. I'm just going to add them for you. You can verify that that adds up to 3/4 later. And then x is multiplied by 2/3. We're going to divide by 2/3. X equals 3/4 divided by 2/3 becomes 3/4 times 3/2, which becomes 9 over 8 or 1 1/8. What do you think? I know. One last little thing to show you. It's going to take us about 5 or 10 minutes max, and then we're done. And I'll do just a quick review for the test, because I managed to squeeze pretty much everything that's on the test in the class today already. So, one thing I want to show is this. What does this mean? Yeah, it's a fraction within a fraction. But remember, we've mentioned that a fraction is really can be thought of as a division problem. So this is just a different way of writing 7/8 divided by 3/5. So this becomes 7/8 times 5 over 3. So 7 times 5 is 35. 8 times 3, 24, which is 1 and 11 24ths. Now it may not stay quite that simple. I might throw in something like 2/3 plus 5/6 times 3/4 squared. How would we do something like that? Exponents first. 3/4 squared. Well, it's going to be 3 squared, which is 9, over 4 squared, which is 16. Now what? Multiplication would be next, right? So I'm looking at this here. Within that, I can cross cancel 6 and 9, be 3 and 2, right? 5 times 3 is 15. 2 times 16 is 32. So now I have 2/3 plus 15 32nds. I need a common denominator now to add. That common denominator is going to be 96. So 3 times 32, 2 times 32 would be 64. 32 times 3, so 15 times 3 would be 45. And now we add. 64 plus 45 is 109. We keep the common denominator of 96. So this is 1 and 1396. Yeah, those get pretty ugly in a hurry. Or another variation of a similar problem might look like this. Two-thirds plus 3/5 over 3/4 times 1 and 1/5. Let's make this 1 and 4/5. Let's make it easier on yourselves. Sorry, 1 and 3/5. Sorry. Make it easier on yourselves. This, remember, we have the fraction bar across here, which tells us we have to do everything on top first. Then we have to do everything on bottom, and then we divide. So we're going to do the top first. 2/3 plus 3/5. We need common denominators, which will be 15. This is going to become a 10/15. This will be 9/15, which adds to be 19/15. Now, normally we would split that up into 1 and 4/15. Right now, I am leaving it as 19/15. Can anybody guess why? Well, once I do the bottom, what am I going to do with this? We're going to divide. We're going to change it to multiply. We're going to divide. We'll change it to multiply to calculate it. But when I divide or multiply, I have to have improper fractions anyway. I can't use mixed numbers. So there's no use converting that to a mixed number just so I can convert it back to an improper fraction. On bottom now, 3/4 times 1 and 3/5. The 3/4 isn't going to change, but what's going to happen to the 1 and 3/5? 5 times 1 is 5 plus 3 is 8/5. Into an improper fraction. And then cross cancel. 4 and 8 can both be divided by 4 to give me 1 and 2. 3 times 2, 6. 1 times 5, 5. 6/5. Now, again, I'm going to leave that improper because now I have to divide. I have now 19/15 divided by 6/5. What do I do from there? Yeah, it's 19/15 times 5/6. And then cross cancel the 15 and 5, 3 and 1, or 1 and 3, however you look at it. 19 times 1 is 19. 3 times 6 18, which is 1 and 1/18. So it's just a matter of staying patient, going through the steps, making sure you verify your calculations through fractions. One last example, then we're going to hang her up for the day. What would I do with this? Throw it away. Well, this, remember, is divide. So this is x to the 5th over 24 divided by x squared over 8. What would I do with that next? Well, x to the 5th over 24 times 8 over x squared. Remember, I changed my division into multiplying by the reciprocal. Now, this one's a little weird because there's not numbers everywhere and there's not variables everywhere. One way we can calculate these, the simplest way to do this one would be just this. X to the 5th times 8 is 8x to the 5th. 24 times x squared is 24x squared. And then just reduce it. 8 over 24 reduces to 1/3, right? Both of them divide by 8. Right? How about the x's? Where's the x going to end up? Top or bottom? Top. What power? 3. So there it is. 1x to the 3rd over 3 would be my answer. What do you think? The last 2 days I realize have been very, Normally, you got to remember what we've done in the last 2 days would normally be spread out over about 2 weeks during the semester. So I realize there's a lot of stuff here. There is a quiz. I believe it's quiz 6. But there is a new quiz due tonight at 11:59 p.m. There is new homework due for Thursday in class. And Thursday will be test 2. I've asked for it to be available by 8 o'clock at the other site. So if you want to start early, please feel free. I will try to be here by 8 or 8:15 to start here if you want to as well. I think you guys have had enough.